to tune in and watch the math. Who knows?
Maybe she has to clean out her bank set, so don't spoil it.
Well, I've never been. It's night.
Oh.
I don't think so.
I have HBO.
They started coming out with too many originals.
Okay.
And taking away.
I just watch HBO Max.
If they had maybe an original about quadratics, would you watch it?
No.
All right, moving on. So there's a lot happening today, but I promise by the fourth example, you'll kind of get the hang of it. So no complaints yet. All right. So we've talked a lot about the x-intercepts, right, of a parabola. And I kept saying, we're not ready to do the vertex yet. We're not ready to do the vertex yet. Today's the vertex day. Where now we know where the peak or the dip go. By peak, I mean like if it goes up, it's a maximum. If it curves down, it's a minimum. Okay, so up here it says find minimum value. I need you to write or maximum. Because it's the same strategy. This just happens to be a minimum because it's a dip. So what that means is we're going to find the vertex of the peak or the dip, right? Peak is our maximum, dip would be a minimum. So in theory, after today, I could give you a quadratic formula. You could determine the x-intercepts and the vertex, and you could draw the parabola.
So is the vertex pointy one?
It's where the middle between each side, right? It's the direct middle. So it's where you would have the mirror image of the parabola, to the right and to the left. Okay, so this is already worked out for us. There's not a whole lot to write here. We're just going to look at this example and kind of figure out what each thing means, right? Okay, maybe I should turn the lights out. Do you think that would help?
Yeah.
Maybe focus a little bit and turn the lights out. Some people that are having trouble.
Yeah, that helps.
Perfect, crystal clear. Okay, here we go. So what we have here is a suspension bridge, and there's a cable that's connected to two pillars, right? You can kind of see them on your drawing. So what we're looking at is this cable right here. That's what we're focused on. And we have the pillars. Let's see how this is labeled with your y-axis and your x-axis, right? So in order to find this point right here, the vertex, we use this formula, opposite b over 2a. Okay, but we're going to write it as negative b instead of the negative being out to the side, and then 2a. We know how to find our a, b, and c, so this is easy. We just substitute in the values. Now, the thing I don't like about this example, and I'm like, come on, really, is that they have like these ginormous numbers in the formula, in this quadratic, instead of just like normal numbers. But it is what it is, okay? So this giant decimal value is our a. This negative 0.37x is our b. This 552 is our c, okay? X and y are measured in feet. What's the height of the cable above the water? That's what we're trying to find. How high is this cable above the water, which would also be like, how high is the bridge, okay? So what they did is they put the values in. They took this number, divided it by the 2 times this number, and they get 1,888. That right there is the x value of the vertex. And our vertex needs an x and a y, right? So now that we have an x value, this 1,188, we can put it in to our quadratic and get the y value. So you use this formula to find the x. You take the x, you put it in back into the quadratic, and you get your y. So our vertex is 1,888 for our x, 203 for our y. what do the X and the Y stand for?
When the vertex is labeled on the ground.
Well, so this is the height, right? And this is the distance to the middle. So if somebody asked me what's the distance across this whole part of this bridge, I would take this times 2 because this only gets me halfway. So it's over and up. Over 1,888 feet, up 50 is where the vertex is. That's where that cable goes. Right? So I know you guys are thinking like this is ridiculous, but I promise once we start using it, you'll be like, this is not so bad. Okay, so let's go ahead now and we're going to take the information from here and we're going to start applying it because that's the best way, as you guys know, to just jump into it and it'll start making sense. We've got a firework. We all have had some sort of experience with fireworks, right? They're launched, they explode, you ooh and you ah, right?
I have a bad experience with fireworks.
I'm sorry. Okay, the function shown represents the height, h, in feet of a firework t seconds after it's launched. The firework explodes at its highest point. All right, so you can kind of see how it goes up, and then they show like this dotted line of where it would go down, right, if a firework were to continue on its trajectory. Okay, so we have h equals negative 16t squared plus 128. We could also say y equals negative 16x squared plus 128x, right? So we have t in the place of our x values, h in place of our y value. They just decided to do that instead of x and y, but we're still finding the vertex, which is going to be x and y. Everybody see what I did there? I replaced the t and the h with x and y. Didn't change any values. Are we good? Okay, so now we're going to find the x value of the vertex. We're going to use that opposite b over 2a. So what is the opposite of our b value? What's our b value?
No.
128x.
128. So it's going to be negative 128. 2 times negative 16. Because this is our b, this coefficient. This is our a, negative 16. So then we end up with negative 128 over negative 32, which is going to give us 4. So the x value for my vertex is a 4. And that's the time. That's also the t up here, right? Are we good so far?
Yeah.
We just put the numbers into the formula, did our magic, and we got 4. Now we're going to take this 4, we're going to put it back into the quadratic, and we're going to find our y value. We're going to substitute. So y value of the vertex. Y equals negative 16 times 4 squared plus 128 times 4. Is there anybody that doesn't understand where this came from? I took the 4, put it in where the x's are. So then I end up with y equals negative 16 times 16 plus 512. So now I have the time and the height, which will give me the vertex. The time matches up with my x values. The height matches up with my y values. Yeah?
Yeah.
Not so bad. When did the firework explode?
4 seconds after.
4
it's
seconds. How high was it when it exploded?
256 feet. 5 feet.
Yep. Come on, it's not that bad. It's not that bad. All right, let's pretend that that would continue going down, like finishing the parabola. How long would it take start to finish?
4
4
seconds.
seconds.
8 seconds.
8, because it's 4 up and 4 down, right? So if that were a thing with fireworks, it would be 8 total seconds.
Or they should make flowers where you like send them up in the air and they come out and you make
Okay. Turn the page. Let's try another one.
Pop things, like a mini
the cheek would be like 4
like drop
Oh wait, no, it's not.
All right. We have a function. Again, we have h and t, but we know this is really y and x. We have a horse. How many seconds after it jumps during a steeplechase? So I don't know a whole lot about horse situations, equestrian, but I'm picturing like a horse jumping over like a little fence.
They're weird.
Wait, is it like a race thingy? Like after
I think it's like an equestrian thing.
is that?
Like people who ride horses and get judged on how well they handle the horse and the jumps, and if the horse doesn't hit the bars when it goes over them.
Is
Yeah.
that the person's fault?
It's usually how they
It's,
train them.
I mean,
Would that be the person's
yeah,
fault?
so the person is supposed to have enough control over the horse to be able to guide the horse into getting over the.
Horse
It would be
is
pretty easy.
Yeah.
horse thing.
Dog.
Face.
My dog just does whatever he wants.
Okay, so we're first going to find the x value of the vertex, right? So we're going to use opposite b over 2a again. We've got this function here. Maybe you guys want to write y and then x and x, so you know that these are actually the x's and y's, the t and the h's. So what's my b value? It's going to, well, it's 16, so it's going to be negative 16, the opposite of b. And then my a is negative 16. So then I end up with negative 16 over negative 32, which simplifies to 1/2. And this is the time, right?
So is this half a second?
So 1/2 a second. So one of the questions is, when does the horse reach its maximum height? This is the vertex. That's the highest point, so it's going to be 1/2 a second to get to its maximum height, right? But now we need to figure out what is the maximum height. So we're going to take this 1/2 and we're going to put it into this quadratic. So the y value of the vertex, we're going to do negative 16 times 1/2 squared plus 16 times 1/2. I put the t value into the quadratic. One-half squared is 0.25. So negative 16 times 0.25, 16 times 1/2 is 8. So I get negative 4 plus 8. So I get 4. This is the height. Remember, this h of t is just like saying y, right?
So 4 feet is the height.
So my vertex is 1/2 and 4. Remember, 1/2 is the time, 4 is the height. So now we can answer questions A, B, and C because we know the vertex. So the first thing we had to do was find the vertex. Then we can go back and interpret it to figure out what's happening with the situation. When does the horse reach its maximal height?
Half a second.
1/2 second. Can the horse clear a fence that is 3.5 feet tall?
Yes.
By how much?
A half
0.5
minute, 45.
of a feet.
You could say 0.5 feet. You could say 6 inches. Right? 6 inches is half a foot. You could write 1/2 foot. How long is the horse in the air?
A whole second.
A whole second. Chase, how did you know that so quickly?
Because if it gets to its maximum height in half a second, fall for half a second.
Yep.
Or
Half a second up, half a second down is 1 whole second.
What if it's double jump?
Well, Vince is adding scenarios at this point. I feel like he needs to get kicked out of class.
Okay. One more example and then we're done.
Yay!
Because then you'll do the next 2 by yourself tomorrow.
No.
You have everything you need. Guys, I'm not trying to trick you. They're all very similar type problems.
It
do
seems
great.
like it takes so long.
It doesn't though. It doesn't. Nope, you'll be fine. Okay, we have another bridge here. This one's slightly easier to see. Let's draw little squiggles here so we don't get the 2 questions mixed up. Here we go. The cable between 2 towers of a suspension bridge can be modeled by the function shown, where x and y are measured in feet. The cable is at the road level midway between the towers. Cool. All right. So we still need to find we just need to find our vertex. We're going to do the exact same thing we've been doing this whole time. So x value of vertex. Opposite b over 2a. So b happens to be -1, so our opposite of b is going to be 1. 2 times, now a is a weird fraction, 1 over 400. So I'm going to turn that fraction into a decimal.
That would be point. Yeah, not even good.
It's going to be 0.0025.
I was not gonna get that right.
So then that's really like saying 1 over 0.005. And if you change that into it, if you actually do the division here, which you guys are thinking, that's going to be ugly. It's not really. It's 200.
Oh, I know. Yeah.
Yeah.
Mm-hmm.
Yeah. Then you didn't know.
Because this number, 0.005, will go into the number 1 200 times.
Yeah.
Tim said yes as soon as I said yeah.
So again, don't let this fraction just put it in there. Do your magic on your calculator. You'll be fine. So that's our x value. And everything is measured in feet, right? We don't have time here. We're just talking distances for this one. So that tells us how far over to go on this bridge. Remember, they said it's midway. So that tells us we're going to go over 200. Now we need to find our y value. So we're going to say y equals 1 over 400 times 200 squared minus 200 plus 150. So I put those 200s in where the x's were in my quadratic. So I'm going to have y equals 0.0025 times 40,000 minus 200 plus 150. That 5 looks weird. So then you end up with y equals 100 minus 200 plus 150. So we have our vertex here. The 200 is the distance to the midway of the bridge. The 50 is the height of the suspension over the water. Okay, now we just have to answer these 3 questions. How far from the tower shown is the lowest point of the cable? From each tower shown? 200 feet. Right? Because it's 0 to 200. How high is the bridge above the water? 50 feet. Domain and range. Woo, you guys love this. Okay, domain, remember, is all the x values. So how far is it between these 2 towers? 400. Who said 400? Isabel, how do you know that?
Almost 2. 2 plus 2.
Yep. If it's 200 halfway, so our domain, wait for it, is between 0 and 400. All of those values between 0 and 400. Our range, remember we're talking about this darkened parabola. So we know that this is at 50. And what is our y-intercept? What is our y-intercept of our equation? 150. So our range is going to be between 50 and 150. So our parabola is anywhere in between here and here. That's our domain and our range. So tomorrow's assignment will be to figure out the situation with the dolphins and the fountain shooting water over a river.
Oh, we have to find the
The
domain.
dolphins should know how far they jump by themselves.
No, there's no domain and range.